Hey guys, welcome to question FM143 of the Further Maths Fortify study guide. This question reads, in preparation for a jelly bean eating contest, Ferris eats more jelly beans each day following a geometric sequence. On day 1 of training, 50 jelly beans are consumed. On day 2, 60 jelly beans are consumed. And on day 3 of training, 72 jelly beans are consumed. If Ferris keeps increasing the amount of jelly beans he eats at this rate, how many jelly beans will he eat on his 7th day of training? Select the answer closest to the nearest whole jelly bean. So there's a couple of ways that we could finish a question like this or do a question like this. We could either use a recurrence relation to get us the answer, since we're not too far away. We're at day 3 at the moment and we just need to get to day 7. Or we could use an nth rule to get us straight to day 7. I'm going to show you both ways, but I definitely recommend practicing and using nth rule as soon as you don't have to go straight to the next value in a sequence and you're jumping a few. Nth rules will save you a bit of time. So if we want to create a recurrence relation for this sequence, we would say first of all that V1 was 50. That's going to be our starting point. Now I've used 1 instead of 0 because it's his first day of training, so we're attributing a value of 1 to that value of n. And then we're going to write Vn plus 1. Now we need a rate. We know this is a geometric sequence. We can see that it's increasing at a certain rate, so we need to find that rate. And the easiest way to find that rate is going to be to take our day 2 value and find it as a percentage of our day 1 value of 50. So this should give you an answer of 1.2, which hopefully you're starting to get familiar with the conversion of decimals and percentages. This would be the same as 120% or a 20% increase. So finding 120% of something is to find a 20% increase of it. To double check that this 1.2 is the rate that we want, we would take day 3, a value of 72, and find that as a percentage of the value of day 2, 60. So 72 over 60, that's equal to 1.2. Once again, 120% or 20% increase. So 1.2 is our rate in this scenario. So we plug that into our recurrence relation, 1.2 Vn. Cool. So from here, we can find day 4 now by saying, well, our value for day 4 is going to be 1.2 times our value for day 3 of 72. So that's going to be 86.4. Day 5 is going to be 1.2 times 86.4, 103.68. Day 6, 1.2 times 103.68. It's going to be 124.416. And day 7, the day we've been looking for, is going to be 1.2 times 124.416, which if we whack that into a calculator, should drop out 149.2992, which of course roughly rounds to 149, meaning that our answer at this stage is looking like B. Now I'm also going to show you a way that we can do this using an nth rule. I prefer this way because I think that it gets you to the answer faster. You saw here we had to do 4 different equations to get to the answer. This narrows it down to just 1. So we start our nth rule with Vn equals. Now we're using a value of V1. We haven't been given a V0, we've been given V1, or we've chosen to use V1 in this scenario. So when I times by my rate, we would normally put it to the power of n. But since we have a value that is already 1 step into our sequence here, we're going to use n minus 1 so that we don't apply an extra rate, an extra multiplication of our rate where we shouldn't. So now filling in the blanks, V7 is going to be equal to, our value of V1 was 50, times 1.2. We've already said that n is equal to 7, so n minus 1 is going to be 6. If we plug this into a calculator, 50 times 1.2 to the power of 6 is also going to drop out 149.2992. Once again, roughly rounding to 149, and still option B. So I prefer this method over that one. I think it's much faster. You sort of saw it in action there. It's one calculation as opposed to four, but I'll leave it with you guys as to what you prefer. If you guys have any questions on how we did any of this, please drop them in the comments below. Otherwise, I will see you in the next video.